Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, we will deep dive into the three-tier architecture model and we will also understand how to deploy a three-tier architecture model onto a Kubernetes cluster, which is AWS EKS. To explain you all the design of three-tier architecture model, what are the different components that are usually involved, what is a microservice architecture, how to write Docker files, how to write Kubernetes resources, Helm charts, and finally to deploy it to a EKS platform, we need a project. And I have a demo project here today. This project is called as Robot Shop. Basically, it's a demo e-commerce project that sells robots and some artificial intelligence products. The reason for choosing this demo project, one is it is built or it is written using different microservices, various microservices, and each microservice is written in a different programming language. There are a couple of databases that this project use. There is RabbitMQ, Redis for in-memory data store, and there is also a very good front end that you can see. So using these different components, you can understand three-tier architecture in a better way. And also, if you look at the functionalities of this demo project, which is quite similar to what you see in a real-time project. For example, there is a registration page which allows users to register. There is a login page where you can log in. For example, I have already created a login. So now I have logged in to this e-commerce website that sells robots and artificial intelligence products. Now I can go through this catalogs, which is basically different categories. And let's say I want to buy this robot. So the image for this robot is available. There is also a ratings page, which explains what is the rating of this robot. And you can also see the pricing of this robot. If there is any discount, you can see the discount that is available for this robot. And you can add it to cart like you do for Amazon or Flipkart or any e-commerce website. And once it is added to cart, you can go to the cart, you can click on the checkout button, and then the shipping part comes into picture where I can say that India region and search for Hyderabad. Click on calculate, which explains me what is the distance and what is the cost for the product. This includes the shipping charges and everything. Now, once I click on the confirm button, then there is a payments page. Of course, right now I did not integrate it with any payment gateway, but this demo project also provides an option to integrate with a payment gateway. Now I can directly click on pay now and my order is shipped. So you can see order ID is provided and this order goes into the messaging queue where it is added to the queue of this project where there are different users trying to put orders for different kinds of robots. So this is the usual flow of any e-commerce application. So that's the reason for choosing this particular demo project. This project is actually written by IBM folks. So they have a product called Instana, and to demo their project, which is a application performance monitoring tool, they use this demo project. What I've done is I created a fork of this demo project and I've made some changes to this demo project. And also what I've done is I made it easily deployable on EKS. So I've added some steps for EKS and made some changes like I've mentioned. So we will learn the entire three-tier architecture model using this application. We will understand what is three-tier. We will learn the high-level design. Like you can see here, this project has different microservices, couple of databases. There is Redis, there is RabbitMQ for messaging queue. You have a very good front end, and there is also Nginx. So what else you can ask for learning a three-tier architecture model? Now, what I'll do is before explaining the high-level design of this project, high-level design is very important to understand because once I explain you the high-level design, you will understand why there are so many microservices and you will also understand what is the reason for having different databases and how they communicate with each other. Now, before I do that, one thing that we need to do is we need to create a EKS cluster. So if you have created EKS cluster in the past, it takes a lot of time. So right now this project is deployed on my local system. What I'll do is I'll stop this application. Now this application is stopped. It's no longer available on my local system. And I will create a EKS cluster, which is just firing one single command. And then we can proceed with our three-tier architecture explanation. Even if you are trying to perform this demo, do the same thing because EKS cluster creation takes a lot of time. So just go to this EKS cluster setup. I'll explain this setup, but for now, let me just fire this command. So this is my terminal. You can take any terminal. Only prerequisite is you need to have EKS kubectl, and AWS CLI installed. I'll talk about the prerequisites when I explain the practical part. So EKS create cluster. Let me change the name of it to demo cluster EKS robot shop. Now let this do its job and let's go back and try to understand first what is a three-tier architecture model, right? So you all might have heard about three-tier architecture model. This is quite popular because any real-time applications, like any applications that you use on a day-to-day basis, it can be Instagram, Facebook, Amazon.com, Flipkart, Myntra, whatever you are using on a day-to-day basis is a three-tier architecture model. But what exactly is a three-tier architecture model? It's very simple. Three-tier architecture model are applications that are written using three different layers. Now, what are these layers? These layers are nothing but there is a front end, which is user interface. There is a backend, and there is database, which is also called as presentation layer. This is called as data layer, and this is called as logic layer. If we take the same project as example, when I was trying to explain you, when you see the robot shop application, basically you are looking at the user interface of that particular project. Now the user interface comes in this particular layer, which is presentation layer or the front end layer. When you click on a particular robot, when you want to check out a particular robot, you get all the details of that particular robot. You get the image of the robot, you get the description of the robot. All of these details have to be stored somewhere, which is typically stored in a database, right? When you see the image of the product, when you see the description of the product, the pricing of the product, everything is stored in database. But how does the information in database, when a user clicks on a particular robot, how is this information displayed on the page? So there has to be a backend. So backend is the one that is responsible when a user performs an action. For example, you go to Amazon.com and search for a product. Let's say you want to buy iPhone and you click on the iPhone product. Immediately you see different kinds of iPhones. You see what are the different options that are available. Basically, these details are fetched from the database. But when a user performs this action, of course, these details are fetched from the database, but there has to be someone who is coordinating between your front end and your database. Basically, that layer is called as backend or logic layer. This is where developers write application in Java, Python, Golang. And what exactly it does? It acts as a mediator between user interface and backend, and database, where when a user search for a product, if we take e-commerce as an example, that product is looked in the database and the details of that product is displayed on the front end or the presentation layer, right? So I hope it is clear what is a presentation layer, what is a logic layer, and what is a data layer. Like I told you, on a day-to-day basis, most of the applications that we use are three-tier applications because all of these applications have a very good user interface. They have database, and of course, without a logic layer, that's not at all possible. Now, let's try to understand the high-level design of this robot shop project. If you understand the high-level design, it makes things very easy to understand what and why are different kinds of components used. And because this is a demo e-commerce project, understanding the high level design of this project will also help you understand the high level design of most of the e-commerce projects, such as Amazon, Flipkart. More or less, they use the same kind of high level design. So that's why instead of just explaining you why different microservices are used and why MySQL, RabbitMQ, Redis is used, firstly, let's try to write down what are the different workflows that are involved in this project. And then let's try to convert these workflows into components such as microservices, databases, etc. So typically there are two workflows. One is the user workflow. Second is the admin workflow. It's not admin workflow, but the application workflow, which I'll talk about. But firstly, let's try to understand the user workflow. Right? Of course, I have explained the user workflow at the beginning of the video, but let's try to write down and convert it into components. Firstly, once the user goes to the application or the project user interface, user has two options. One is user can move to the registration page or user can go to the login page. Depends upon if the user is a first time user or user already has an account with this project. Once user performs any of these actions, then the next thing user gets to do is switch to the catalog page. In the catalog page, again, there are two different kinds of catalogs. If you go to Amazon or Flipkart, there are different catalogs or multiple catalogs such as men's clothing, women's, accessories, child section. But here we just have two catalogs because this demo project is only selling two kinds of products. One is the artificial intelligence products. Second is the robots. Now let's say user goes to one of these robots and selects a robot. Immediately, user can see the rating for this particular robot. And if user likes the rating, user can add this particular product to the cart section. After that, user can move to the payment section. As I told you, this project can be integrated with any payment gateway, but right now it's not integrated. Then if user is interested in buying this product, in the payments page, user can provide the shipping details. And finally, if the shipping details are correct and if the product can be shipped to the shipping address that is provided, your order is complete or the user's order is complete and user gets a order ID. Now this is again very important. User gets a order ID. This we will use in the second workflow, but let me complete the user workflow first, right? So these are the different things a user gets to perform from the application point of view. Now, if you watch carefully here, catalog, rating, cart, payment, shipping, all of these things need logic, right? That means each of these components that you see here or each of the parts of the application that you see here should be written by the developer or by the people who are developing this particular project. Now it's up to them if they want to write this entire logic in one single application or as part of one single binary, then it is called as monolithic application, right? Because for catalog, a developer has to write a few lines of code. For ratings, there is a different kind of logic. For adding the applications to the cart, there is a different kind of logic. For payments, there is a different logic. And for shipping, there is a different logic. Let's say all of these components that you see here together can be written in, for example, can be written in 10,000 lines of code. It's up to the developers if they want to put into one single folder or one single binary. End of the day, if it is created as one single binary, we call it as monolithic application. But the good practice is to make these components individually deployable, and that architecture is called as microservice architecture. And this repository follows the microservice architecture, which is quite common in today's world. Most of the applications that you see are written in microservice architecture. Simple answer is, let's say tomorrow, if there has to be some changes made to the catalog, along with AI and robots, we want to add one more category, something related to machine learning. Now, if all of these components are written as one single application or a monolithic application, any changes made to this catalog might impact the other components as well. If there is a QE engineering team, right, they have to verify all the components, even if this catalog piece is changed. Whereas if each of these components have different APIs, each of these components can be independently deployed, then it becomes very simple that the developers of this particular team can make any changes, and they can only test the catalog related things. They can use the APIs to test this particular thing, and they can be rest assured that the changes made does not impact ratings, cart, payment, and shipping. Imagine companies like Amazon, they have probably 500 to 1000 microservices or even more than that. Now, in such cases, if they write the complete Amazon.com in one single monolith application, any single line of code, Amazon might have millions of lines of code. Any single line of code can impact other millions lines of code, and you need to test each and every piece of code, or you need to perform a regressive testing on the application. So to avoid all that, microservice architecture is the best, right? Now, if you go to this particular project and if you go to the GitHub, you can clearly see how this application is written in the microservice architecture model. Like we were talking about catalog, rating, cards, payment, and shipping. You can clearly see a folder for each of them: shipping, ratings, payments, catalog, cart, right? In real life use cases, because this is a demo project and this is a very small project, everything is written in one GitHub repository. But usually the folders that you see here will be different repositories altogether, right? For example, payments. Here in this case, payments is written in Python. And if you go back and search for ratings, here ratings is written in PHP. Of course, it's not mandatory. All the microservices can be written in one single language. It depends on the developers and the architect of that particular team. If Amazon has 500 to 1000 microservices, let's say, it can be possible that all the 1000 microservices can be written in one single programming language such as Golang, or probably 998 microservices can be written in Golang, and two microservices might be using Python because of the nature of those microservices. It's quite possible. Or two microservices might be using PHP. So it doesn't matter if each microservice is written in different programming language or written in the same programming language. Now, the reason why different microservices here are written in different programming languages is because any DevOps engineers or anyone who is looking at this project gets to see different Docker files, and they can understand, looking at this Docker file, how a Python application can be built, how to write Docker file for the Python application, or how to write Docker file for a PHP application. Like this is a PHP application. If you go to this, you can see the Docker file for the PHP application, right? So this way, this project tries to explain how to write the microservice architecture and also how to write a Docker file for different programming language. Now you might say, okay, Abhishek, here I understood because you are talking about it. Let's erase this part and let me try to explain you the databases part as well. Then we can move towards deploying this application, right? So Abhishek, you were talking about different kinds of applications here. Now I understood that there is catalog, payments, ratings, but where and why database is used. Now, if we try to understand this in the three-tier architecture model, you already know why user interface is used, right? Whatever you are seeing on the screen for this particular project is written in Angular, and this forms the presentation layer of the project. The demo application that you are seeing, right? The presentation layer explains the user interface. Then I have just explained the microservices part, right? Where there are different microservices for this project, such as cart is a microservice, catalog is a microservice, payments is a microservice, right? And I've also explained about shipping. Then there is user, where user has the registration page. So these are the different microservices. Now, this is user interface. This is the logic layer. Now, where did the databases come from? Okay. So again, if you take a look at the project that I've shown at the beginning of the video, like if you go to the catalog, right? In catalog, once you click on a product, you see images, you see the description of the product, and you see the cost of the product. Now, all of these details are fetched from the database. So for catalog, you need a database. Similarly, user. Now, if the user already exists, user provides the username and password, but this has to be validated against a database, right? Let's say I provide admin. Did a user called admin already log in, or if a user has registered to this uh, uh, platform, then we need to store the user details onto the platform. So that's why we have a database for the user as well. Then again, you have cart. So cart is very important. Let's say you add one of the products to the cart, and for some reason this application went down, or you have logged out of the application. Next time you log in, you should see the application or the product is already available in the cart, right? Let's say you go to amazon.com, you place an order in the cart. 2 days, 3 days, when you come back, your order will still remain in the cart. So for this, we don't need a database, but we need a in-memory data store. That is, we need Redis, right? Why we need a in-memory data store here? Because next time when the user logs in, this cart application will understand from Redis, okay, this user has already added some products to the cart. And once the user logs in, show that this user has one application or one product in the cart. We can also use in-memory caching here. Instead of in-memory data store such as Redis, the programming language that you use also has some in-memory cache. But the problem here is that if you are using an in-memory cache, what happens is, for some reason, if this application goes down, right, all the details of the user, what user has added to the cart, are lost. So that's why what we will do is, instead of using in-memory cache, we will use in-memory data store such as Redis, and we will create it as stateful set in Kubernetes, right? So if you want to understand the details between in-memory cache and in-memory data store, you can search for it. It's not very complicated, but it becomes totally a different topic if we try to cover that in detail. But for now, for user, there is a database. So what this project does is, for the user details, MongoDB is used. And for the catalog or ratings, right, every product has a rating. This product use MySQL. And of course, again, here, both of these databases can be same, but just to give us more understanding of how to deploy MySQL onto a Kubernetes cluster and how to deploy MongoDB onto a Kubernetes cluster, this product use two types of databases, right? But we can use one single database as well. So overall, there are 6 microservices here, and there are 2 databases, and there is one in-memory data store, that is Redis. Now let's try to go to the project and look at the Docker files of each of them. And finally, we will also move towards Kubernetes and try to deploy it. So if you see here, my EKS cluster is already created. So we are all set with EKS to deploy it. Of course, we need to do some prerequisites configuration. I'll come back to it. Now, if I quickly give you a walkthrough through these microservices, like I've explained, if you go to shippings page, now shippings is a microservice that is written in Java. If you go to the Docker file of it, you will notice how to write this Docker file. So what it typically does, it picks up a Debian image, installs Maven, builds this particular application, and in the multi-stage Docker file, OpenJDK image is used, and the binary that we have built using run Maven package, it is copied to the target, or the target Docker stage. And here we are using the Java command to start this particular Java application. It's a very simple and straightforward Docker file, right? All of these things have straightforward Docker files because they are very simple and lightweight applications. Now, if you go to the ratings, like I told you, this is a PHP application. And if you go to the Docker file of it, we will use a PHP base image, and we will try to copy the HTML page and all, and we will try to run the composer, right? If you are aware of PHP, you will understand how to start a PHP application. If not, you can take a look at this Docker file, and next time when you run a PHP application, it becomes easy, right? Similarly, the Python application Docker files are provided. The Golang based Docker applications are provided. Like if you look at the dispatch service here, so this dispatch microservice is written in Golang, and this is the Docker file for the Golang project. So instead of deploying each of them as Docker containers, what I have done is in the EKS folder, I have created Helmchart for it. So Helmchart is not complicated. If you look at the charts.yaml file, and if you go to the templates folder, what I have done is I have put the Kubernetes deployment file and service file for each of the component. Like if we start from the cart has a deployment, cart has a service. Catalog has a deployment, catalog has a service. Dispatch has a deployment, dispatch has a service. MongoDB, MySQL, payments, RabbitMQ. I'll talk about RabbitMQ, why it is used. Ratings, Redis, shipping, user. For each of this, we have a deployment file and a service file. So this deployment file and service file, what simple thing that you have to make sure is whenever you are using a deployment file, you have to provide the container port for each of them, and rest all I have just provided for basic information. Because I am using a Helm chart, you can modify these things. I've just added them in the values.yaml, but for this particular project, you don't have to use any advanced Kubernetes configuration such as pod affinity, or we don't have to set up any webhooks, admission controllers. Nothing is needed. So if you go to the values.yaml, you will notice most of the values.yaml is empty, right? Most of it is empty. Only thing that I focused on is the image details, right? What is the repo? So this entire Docker images, the Docker files that I've shown, all the Docker images are built, and they are all available in the Docker repository called Robot Shop, and all the images are pulled from the latest version. Perfect. So now let's try to move towards the EKS and see how to deploy this project. While deploying, most of the things becomes very clear for you. So let's go to the EKS folder and let's start with the prerequisites. First, do we have all the prerequisites? In my case, EKS CTL is already installed, AWS CLI is installed, kubectl is also installed. If you want to know how to install EKS CTL and how to install all these components, you can refer day 22 of AWS Zero to Hero repository or day 22 of AWS Zero to Hero playlist. I have clearly explained, but you can also follow these links. They're pretty straightforward. I'm not going into the details of how to install EKS CTL and AWS CLI, right? So prerequisites, we have already completed. EKS cluster setup, I have already installed the EKS cluster using this command and I have shown you. Now let's move to the next one, that is OIDC IAM configuration. If you don't understand why this OIDC IAM configuration is required, it's very simple. Like EKS is one service in AWS, and let's say you are deploying different pods in EKS. In our case, we have 6 to 7 microservices, we have databases, all of these things will be deployed onto EKS. And let's say one of these microservices, in our case, we have Redis, right? Redis is deployed as stateful set. And whenever you use a stateful set, of course, you need a persistent volume, right? So this persistent volume, in terms of AWS, we use EBS volumes. That means the EKS service has to talk to EBS. So whenever you want to do that, what you can do is, by default, Kubernetes creates service accounts. We can integrate the Kubernetes service accounts with AWS IAM so that the service accounts in Kubernetes, right? Any pod that you create in Kubernetes has a service account. And this service account, if it is integrated with the IAM roles or IAM policies, then your Kubernetes pod, it can be Redis or it can be ratings or any pod, can talk to other AWS services, right? Best example is when you are using stateful sets in EKS. In our case, I'm using Redis as a stateful set, and this Redis should communicate with the EBS volumes because persistent volume is used through EBS. For this, what I'll do is I will integrate the service account of resources that are deployed in EKS with the AWS IAM so that it gets access to the AWS resources. Got it? So that's why our next step would be to go back and firstly, let me take this terminal. Let me get the terminal here. Right? So the first step would be, as per the document, export the cluster name. So what is my cluster name? If I go to my EKS dashboard, I just created a cluster, and in your case, the cluster name, if you want to put it different, no problem, but make sure for each of the command, you are modifying the cluster names. I created the cluster in US West 1. Right? Of course, when I showed you the command, I did it in East 1, but there was an error, so I slightly modified it. Right? Now the cluster is available in US West 1. Perfect. So what is the name of the cluster? Let me copy it, and in the command, let me explode the cluster name with this. Now, once I've exported the cluster name, where is my GitHub repository? Let me go to that. Perfect, it's here. The next thing is I have to get the OIDC ID. So for that, just copy this command and execute it. If the OIDC configuration, if you look here, an error occurred. Did I change the region name? Let me see that. Okay, I think this is because my AWS is by default configured to US East 1. So what I can do is I can just run AWS configure one more time, and I can change the default region to US West 1. In your case, this is not required. If you are doing it in US East 1, then you don't have to change anything. So let's see if this works now. Perfect, it worked. And now let's try to copy this. My bad. Let's copy this one, AWS IAM, and see if there is anything that is already created. the OIDC provider, it's not created. So I can move ahead and create it using this command. Right? Just if I have to repeat, in my case, I'm creating the cluster in US West 1 because the US East 1 region, there is some issue with the resources for the availability zone that I'm trying to create. So I just try to switch it to US West 1. In your case, you don't have to worry if it works in US East 1 for you. Perfect. Now the OIDC configuration is also complete. Now I can proceed with ALB configuration. Why I need ALB is because I want to expose this robot shop application to the external world. Initially, in the beginning of the video, when I showed you this application, it was deployed on my laptop. So I was able to show you. But if we are deploying it on EKS, we need to expose this using ingress and ingress controller, right? So only for the web application that is hosted in Nginx, what we will do is we will create an ingress along with deployment and service. So for that, firstly, to create deploy ALB controller, that is ALB ingress controller, we have to follow these steps. Where firstly, I'm trying to create an IAM policy, then just download this particular IAM policy. It already exists. Perfect. So now create this IAM role. And when you try to create this, what you need to do is just be little careful. You have to update your cluster details here. So what is the name of your EKS cluster? This is the name of my EKS cluster. Perfect. Then namespace, you don't have to change. Put it in the kube system. Last time few people asked me why should the ALB controller created in the kube system namespace? That is because ALB controller is just one instance that watches all the namespaces, and the people of ALB controller, the developers, they have decided to use the kube system namespace. And initially, most of the ingress controllers were deployed in the kube system namespace only. Later, some projects moved out of kube system namespace, but for ALB, it's a requirement. Then add your account ID here. So account ID, you can fetch it from here. Let me just increase the font if it is not very clear. Perfect. So now my service account, once it gets created, what we are trying to do now, we are trying to create a service account for the ALB controller. Once it is done, we will add the Helmchart for the ALB controller and we will install the ALB controller. This step is very, very important, and sometimes it might take time. And sometimes your cloud formation, basically the service account and the ALB controller, whenever you are trying to create, there can be some errors. In case of service account, I have noticed sometimes the cloud formation fails. What you need to do is you need to go to this particular cloud formation stack, delete it, and only then recreate. If you try to recreate, it fails unless you delete it. Okay, right now it got successfully created. And what I am going to do now is add the Helm chart. I think in my case, I already have the Helm chart. So I don't even have to update. I'll proceed with installing the Helm. Right? This is the Helm chart for ALB controller. Again, modify the cluster name. So be very careful whenever you are doing it. Cluster name, and then region is US West 1, and VPC ID, you can get it. Just go to your cluster settings, go to network, and just copy paste the VPC ID. You can also create a new VPC altogether, but I am fine. Two arguments. Okay. Basically there is issue in the copy pasting. What I can simply do is just remove this hyphens. I've noticed this because of wrong formatting in the MD file. I think I have not done it correct. So I'll try to update this command, but if you also get such error, so you don't have to panic. Just try to modify it. Perfect. Now I think it will work. Let's see. So once this Helmchart creates the ALB controller, make sure you verify that your ALB controller pods are up and running. Unless this step is done, do not move to the next one, right? So we will make sure that the ALB controller pods are up and running. Right now it says ALB controller is installed, but if you go here, you will notice that my pods are up and running. It's so quick, but sometimes it takes time as well. So you need to wait. And one thing to mention that I forgot to mention is the EKS cluster that we created this time. Last time in day 22 of AWS Zero to Hero, when we deployed 2048 game application, we used Fargate, and this time I'm using EKS with EC2 instances. There are two reasons for it. One is last time I did not cover EKS with EC2 instances, so I explained the Fargate way. And the second reason is the Redis component that we are using today does not support Fargate instances because I have granted net admin permissions or privilege to the Redis component, which Fargate does not support. And also we are using EBS as persistent volume. That is also not supported by Fargate, right? Perfect. Now this step is also done. Now the final stage is to create the CSA driver or CSA plugin, configure it and add it as an add-on. Why we need this is very simple. If I have to explain this, this can be asked as an interview question as well. Whenever you are using Redis, and most of the time Redis is created as stateful set, right? 99% of the times Redis is created as stateful set because Redis is used as in-memory data store, and everyone wants to persist the state using Redis. So it is deployed as stateful set. And what happens is Redis requires a persistent volume. In our case, because we are on AWS, we mostly use EBS or EFS. And today I'm using EBS as a persistent volume. Now, whenever we create Redis, there are two components. One is persistent volume claim, and second is storage class, right? So when you create a persistent volume claim, storage class will look at the claim and it has to manage to create the EBS volume. Now, for this thing to happen automatically, right? If your storage class has to automatically create it, there needs to be a mechanism. And in AWS, there is something called as EBS CSI plugin. If you add this EBS CSI plugin to your EKS, what happens is the storage class and this CSI plugin together, whenever a PVC is created, EBS volume is automatically created and attached to the Redis stateful set, right? So that's why we will have to deploy this particular thing. Let me do it. EKS create IAM. I'm not going to change the name. Let it be the same. Namespace can also be the kube system. There is no problem with it. Again, copy paste the cluster name. Be very careful. I'm not changing this. You don't have to change anything. Just update your cluster name and execute this command. If there are any errors, we will try to fix it. And next step, once this particular IAM service account is created, just like the ALB controller, we will proceed with creating an add-on. So you will have to follow all of these steps for your real-time applications as well, and probably even more. If you look at this demo application itself, we are creating a lot of microservices. We are creating all of these components, Docker files, Helm chart, right? So you can understand how complicated it gets when you deal with more number of microservices. So now let me go back and update the AWS account ID here. For the ALB controller as well as CSA driver, the steps are pretty much similar. And here in the cluster name, perfect. So now I hope CSA driver, perfect. I feel very surprised today. Everything's getting created very quick. Usually these things take time, the ALB controller and the CSI, but Great. Okay. So if you want to understand more about the concepts that I'm explaining, I have also added some references. You can go through them. Now the CSI driver is also created. The only thing that is left is to deploy this entire project as Helmchart. Like I've explained, you can go to Docker file, create each and every Docker container, deploy the Kubernetes manifest by yourself. But instead, to make it very simple, I have this Helm chart here. Firstly, what I'll do is create a namespace called robot shop and then simply execute the Helm command. Helm chart file is missing. I think I'm at the wrong folder. Let me go to Helm folder here. Yep. Uh, okay. In my local, yeah, in your case, you have to go to the EKS folder. In my local, it's not completely updated. So I'm still here. I've updated in the GitHub, but I think I did not rebase it. That's fine. So what I'm going to do is switch to the Helm folder. So if you see my present working directory, I switched to the robot shop K8s folder. But in your case, please switch to the EKS folder and then the Helm folder because I have modified it. Now, what I'll do is just execute the command, the Helm chart command. This is the one, right? Now, Helm chart will deploy each and every component. Meanwhile, let's again take a look at the chart files, right? How is this Helm chart written? It's very simple. Whenever you want to write Helm chart, there are two important components. One is the chart.yaml. Second is the values.yaml. Then you have the templates folder where you dump all the K8s manifests, right? Now, what is the advantage of using a Helm chart? It's very simple. Let's say you want to reuse this, or a very simple one is if you go to the card deployment.yaml, right? Here you have image name, right? So there is an image repo. For all of these microservices, image repository is the same. If you see here, there are more than 12 deployment manifests. And every time, if I have to update the deployment, uh, the image repository, let's say tomorrow, you have changed the image repository, or tomorrow you want to switch to a different image repository. If you keep that in the values.yaml, right, you can add image followed by a repository name here and version. Tomorrow, if you want to change the version of all the components, you can just change it to V1, V2. Or if you want to just change the repository from robot shop to something else, you can also do that, right? Because this is not a Helm related class, I'm not going into the details of it, but just understand if you have a Helm chart, it makes your Kubernetes resources easily deployable and manageable. So I have dumped all the Kubernetes resources into the templates folder and managing the values through the values.yaml. Now let's see if the Helm chart is done. Perfect. Now let me do kubectl get pods minus n robot shop. Now, all of my pods should be up and running. So there are two pods that are still not up and running, ratings and shipping. Let's wait for them. In your case, it might take 5 minutes, 10 minutes. Please be patient, right? Meanwhile, like I told you, the user interface has to be exposed. So for that, if you see here, kubectl get svc minus n robot shop. There are two ways to expose your applications to external world in Kubernetes. One is you can use the load balancer type service. Second is you can use ingress based services, right? You can create ingress for your service. So here load balancer type service is something that I'm already using, but I don't want to show it through this particular load balancer service because it is not the approach that is quite commonly used. Ingress is quite commonly used and we have already created ingress controller, right? So what I'm going to do is I already have the ingress definition YAML file here. So if you go to the GitHub repository, in your case, if you are cloning this GitHub repository, it's available in the same folder as Helm. You can go to this ingress.yaml and just apply this ingress.yaml. Don't have to modify anything. Just apply it. What is it doing? Basically, we are creating ingress for this service called web, right? And the service port is 8080 because this uh, project creates the web service on port 8080. I'm just exposing it using the ingress controller, that is the ALB controller. So kubectl apply -f ingress.yaml. Now it should create ingress, and in case of ingress, right, I have applied, but still, if I do kubectl get ingress -n robot shop, you will notice that the ingress file, sorry, the ingress resource is assigned with an address. But if you go to the load balancer, right, it will take time. You can search for EC2. Right? We should be in US West 1. In my case, in your case, you can be in US East 1 as well, depending upon that. Now, if I go to load balancer, sometimes it will still remain in the provisioning state. See here, it is still in the provisioning state, so I have to wait for it. This is something that I've created yesterday. Uh, oh, sorry. This is for the web service. When I've exposed the service as load balancer type, it is available here. You can ignore that. But this is something that we are trying to provisioner using ALB controller. If you go to it and if you look at the tags, I think it should be evident. Perfect. It says this load balancer is being created using ingress resource by ingress controller. Once the state is changed to complete from provisioning or active from provisioning, we will be able to access this application through the user interface. For now, let's again go back and see kubectl get pods -n robot shop. Perfect. All the pods are in the running state. So I just need to wait for this one to change to active. And once that is done, I think my application should be up and running. One thing that you need to do is go back to this 3-tier architecture application and explore each and every Docker file, right? Because of the time constraint, I cannot go through each and every Docker file. And people were also asking about CI/CD. If you understand the architecture and if you understand the Docker file, CI/CD is a piece of cake, right? Just try it by yourself. If you still feel you are not understanding and if you're not able to implement CI/CD, I will explain it. But this project requires 12 CI/CD pipelines because there are overall 12 components. So deploying 12 CI/CD pipelines is also very difficult. So just try it with one CI/CD pipeline. Always remember, each microservice should have one CI/CD pipeline. You cannot deploy everything through one CI/CD pipeline. It's not a real-time thing. Even here, the reason why I'm using a Helmchart is because I just want to show you the deployment through one Helmchart. In ideal cases, for each component, you can create or you will create Helm chart for each of them. Like catalog will have a Helm chart, product will have a Helm chart, dispatch will have a Helm chart, right? So creating CI/CD pipelines, just start with one. You can create probably CI/CD pipelines for the payments. Payments is written in Java, I guess, or it's written in Python. You can start with Java or Python one. They are pretty simple. Golang is also very easy. Just go to dispatch and use the Golang one. If you still feel you're not able to do it, I will also explain the CI/CD pipeline. But like I told you, this video is already lengthy. If we add CI/CD pipeline, it becomes too lengthy. Status is active. So now let's click on this DNS name and access it. I'm sure it should work. Perfect. So our IBM stands robot shop is up and running, and this is our project. Now you can proceed with register, you can proceed with login, use the AI commands, use the AI products. You can look at the ratings, you can add them to cart, payments, try each and every workflow. And once your demo is done, please do not forget to delete the cluster. I have also shared the command to delete it. If you go to EKS and if you go to cluster setup, this also has a command to delete the cluster. It will delete the entire cluster with all the components, unlike Fargate. If it is Fargate, you have to do first, you have to remove the Fargate profiles and then you have to do a bunch of things. But here, everything is taken care, right? So this is it for the video, and I hope you enjoyed the 3-tier architecture model and you understood how this works in real time. And it's a big achievement if you have done it. Like if you will be able to follow the demo and if you will be able to implement it with clear notes that is available. The link to the 3-tier architecture demo will also be available in the description. Just try to follow this entire thing and try to deploy it. If you will be able to do it, do let me know in the comment section and I'll definitely give you a shout out because this is not an easy project to implement. Thank you so much for watching today's video. See you all in the next one.